Hey guys, hope all is well. Hope you're all safe, and foremost anything else, I hope you and your families are all doing well. I know it's a weird situation, and I know it's one of those situations where, one, we weren't all expecting to be out this long. We also weren't expecting to not know what was going on. These last couple of weeks, I've been telling you guys to literally just try your best with the assignments because I meant it. I know it was a weird situation for you guys, and I know that this wasn't the way that we always used to do things. With the fourth cycle coming up, I don't know where things stand. I don't know when school's gonna be going back because no one's told us anything. You probably know as much as I do. But without wanting to see your grades drop for the fourth cycle, because we may have to actually do this on a day-to-day basis where I find a way to teach you guys, and I don't want you all to fail, and I don't want you all to be in a situation where you have to figure out these lessons by yourselves with all the slides, because they are difficult to try to figure out some of them by yourselves. And with that said, I figured this would help. I feel weird doing this, but you know what? If it helps a bunch of you actually pick up the lessons, then it's completely worth it. So first thing I'm gonna try is I wanna try to do the first lesson, which is gonna be a lesson on properties of circles. So first thing I want to show you is whenever we're dealing with circles, you got a circle. Hopefully you all know what the shape of a circle is. You have a circle. Most important point on a circle is the actual center, because the center, it's the only point that actually is inside of the circle that gives the foundation everything else. So from that center, you have this segment here. That's called the radius. And literally what we know about the radius is that with the radius, it's always from the center to the side of the circle, anywhere. So you can have a radius from there, you can have a radius from here, you can have a radius from here. And regardless of where the radius is, it always goes from the center, always to the sides. And what we also know is every time you have a radius, what makes a circle is that it's always the same. Everything's all congruent. So if that's 3 centimeters, we know that that's also going to be 3 centimeters, and we know that that's always going to be 3 centimeters. Anything, could be 3, could be 5, doesn't matter. One thing we know about a radius is that all the radii is always going to be the same. So we have a radius on a circle, and there's something else that hopefully you guys have actually learned in elementary school. We have a radius, which is always from the center to the side, and then we always have something else called a, let's say I would draw this now, right? Now we know that that's not a radius just because literally it's a lot longer than a radius, and not only is it going from the center to the side, it's actually going from one side of the circle to the other. That is called the diameter. And sorry about my handwriting again, I'm just getting used to this. But you have a diameter, and the difference between a radius and a diameter is that the radius goes from the center to the side of the circle, whereas the diameter literally goes from one side of the circle to the other, but it always has to cut through the center. Now the one thing we do know about a diameter, it's always going to be bigger than a radius. So let's say that the radius was 3 that we used before, it's always going to be 2 times bigger. So if a radius is 3, let's say, the diameter is going to end up always being 6. And it's always going to be true because it's always going to be double the size. So let's say that the diameter was, I don't know, 10. If the diameter is going to be 10, now we know that the radius is going to be 5. And it's always that. It's the diameter is always 2 times bigger. Always think of it also the opposite. If they give you the diameter, the radius is always going to be 2 times smaller. So always remember, diameter is always the biggest one. Hopefully you guys got that. Now let's see what else we can do with the circle. So we have a circle, we know about the radius, we know about the diameter, we know about the center, which is the most important point on a circle. Let's switch it up now. So draw a circle again, all right? And now the whole point, the major part of today's lesson is there's certain parts, other parts of a circle that we need to focus on. And it deals with angles. So we have the center again. From the center then, we have an angle that's made from the center of the circle. And literally, whenever you have an angle at the center of the circle, this angle here has a name, and it's called a central angle. And again, I'm sorry if I'm in the way, guys, just getting used to it. So literally, the reason that it's called a central angle is because you have an angle that's literally at the center of the circle. And once you have an angle at the center of the circle, it's called a central angle. And the good thing about a central angle, the whole lesson that we're dealing with today, it's dealing with angles and arcs. So you have a central angle, and then we have an arc, which we'll get to in a sec. So let's just say, that that angle is 30 degrees. And what happens is whenever you guys have an angle, a central angle, you're dealing with a circle. And when you have this angle here, it actually opens up to create this arc over here. And that's the focus of today's lesson. Not only is it on central angles, but it's also realizing what the arcs are themselves. So this, again, it's called an arc, ARC. And what an arc is, so the angle, the central angle is always inside of the circle, always touching the center. What we know about an arc is the arc is always the part that's outside of the circle. And we're going to go into more about the outside of the circle tomorrow. But an arc, again, it's a portion of the outside of the circle. So you have different kinds of arcs. And you have a major arc and you have a minor arc, but we'll get to that in a sec. So what the whole point of today's lesson is focusing on this part. We know that the central angle is 30 degrees. And then we have an arc. Let's just call it AC, right? So normally, again, when you have an angle, you would label it with 3 variables. This time we're talking about an arc. And again, the arc is always on the outside. We're talking about arc AC. And whenever you're talking about the arc, which is again the outside portion of the circle, you would literally draw a small arc on top. So whenever you see that, it literally is referring to arc AC. And so what we're going to see now is we have a circle. A circle is always going to add up to 360 degrees. Think of it this way. Whenever you have all the angles that are inside, regardless of what it is, it's still a circle, right? Because if you put everything together, just like my finger, it's making a circle. When you move out, if you look at just the arcs, it's still making a circle. One way or another, it makes a complete circle. Whether the circle is inside or whether the circle is outside, it makes a circle. And the second it makes a circle, it always adds up to 360 degrees. So whether it's a big circle or a small circle, adds up to 360. Now, since that's 30 degrees, the one thing we always know about the arcs that correspond to it, the arc that actually goes with the 30 degrees that corresponds. If the angle is 30, we know that the arc is also going to be 30 degrees. And it goes down to that whole idea again. One way or another, whether you're dealing with the circle on the inside or whether you're dealing with the circle on the outside, it's still a circle. And it adds up to 360. And as long as the central angle is there and it's touching the central angle is always going to be the same measure as the arc. So like if that was 70, the arc that goes with it, that corresponds to it's going to be 70. If that was 100 degrees, let's say, the corresponding arc would be 100. And that's the main focus of today's lesson. It's literally knowing that the arcs that correspond to the central angle is always congruent. And so you know it's 30. Sometimes you'll also see an M right there, which just literally refers to the word measure. Talking about the measure of arc AC. Hopefully that's making a little bit of sense. Again, this is where it feels weird because I'm hoping that you guys are understanding this right now. But good thing about being actually on YouTube and being able to go back and forth is just that you can rewind if you don't understand. You can always feel free, honestly, just send me an email, send me a message if you ever have any questions with anything. We also have on Pearson, I started the other day, is the discussion board. So any questions you guys always have, feel free to ask any questions on the discussion board, on the emails. Feel free. So let's go back to what we know. All right, you have a circle, right? And automatically, a circle always adds up to 360 degrees. Whether it's a small circle or big circle, adds up to 360. And we have a center, and from the center, you have a central angle, right? And you know it's a central angle because, again, it touches the center. And let's just call this, whatever, FL, right? So we have this angle here, and then you have arc FL. So now let's, for example, let's say if the central angle was 20 degrees, we will now know that the measure of arc FL would end up also being 20 degrees. Same idea. If the central angle is 20, the arc that goes with it's going to be 20 degrees, right? And now there are different names for it, and I'm going to put a point here, and I'll explain in a sec. Let's call that H. There are two names for these arcs. This arc right here, and I'll do it in a different color just so you guys can probably see it better. You have this arc here, that's in red, and then you have this arc here, the other entire arc in blue, right? So you have one arc that's in red, FL, and then you have another arc that's in blue, and this one now, you wouldn't just call it by 2 points because FL could be that technically, and if you were to just call this FL, that technically could be FL if you didn't use anything else. So for the one in red, we'll call it FL, and for the one in blue, we'll now call it F, H, L. Because now if you're talking about arc FHL, there's no confusion. You're literally just following the points to show you FHL. And you can call it FHL, you can call it LHF. Doesn't matter. Whether they go one way or another, doesn't matter. Just don't ever call it HFL. Just because you have to go in the order that they're talking about. So they have different names for it. When you're talking about this one, FHL, that's called a major arc. And there's a reason why it's called a major arc. There's this number that you're dealing with, and you all should know it, is whenever you're dealing with a straight line always adds up to 180 degrees. And basically think of it this way, you know that if a circle adds up to 360 degrees, 180 degrees is half a circle. So the way that you always know whether you're dealing with a major arc is always going to be greater than 180. Greater than 180. Which basically, if you had to see the way it looks, major arc is always going to be more than half a circle. So if you have a major arc that's more than 180, you're going to have a minor arc, and that's what we would call this. You would have a minor arc, and the difference is if a major arc is greater than 180, a minor arc is going to be less than 180. Less than 180. And again, you have the numbers. If you always want to think of it this way, is major means it's more than half a circle. Minor arc means it's less than half a circle. And then there's another name too for it, which is once we have all of this, let's say you have a major arc, which is more than half a circle. You have a minor arc, which is less than half a circle. But my question is then, what happens if it's exactly half a circle, right? So what I mean by that is this. If you have a circle, right, and you were to take half a circle, again, it's not a major arc because it's not more than half. It's not more than 180. And it's not a minor arc because it's not less than 180. But when it's exactly 180, it has a name for it. And when it's exactly 180 degrees, it's called a semicircle. And it's literally called a semicircle because it's literally half of a circle. So always remember, if it's more than half a circle, it's a major arc. If it's less than a semicircle, it's a minor arc. Always think, more than 180, less than 180. Hopefully that makes sense. And now the whole question, why do we actually use all this? So a few things that we actually picked up was, we know central angles, right? And let's draw them, just so you can actually see it. You have a circle, right? You have the center. You have this, which again, it's called the radius. So if the radius is 4, let's just say, just making something up. If the radius is 4, you know that the diameter, which would be the whole segment from one side of the circle to the other through the center. If the radius is 4, diameter is going to be 8, always double. And if the diameter is, let's say, 20, the radius is going to be 10. But, yeah, a little bit of review right there. And now we have an angle. And the one thing we talked about, since it's touching the center, it's called the central angle. And with the central angle, it's creating an arc. Let's say we have that. Now let's start focusing on this part right there. And you got a few angles, right? And again, start looking a little bit complicated. Let's say now that I were to give you some measurements. Let's say that this measurement here is 35 degrees. Right? Got that. So now what we know is, and again, I'm sorry about the drawing because it's actually supposed to be straight lines. Let's say, let me draw better. So there you go. All right, you got a straight line. Let's say that that's 35 degrees. And I wanted to start figuring out all these measurements. And I wanted to know, let's call that B, let's call that D, let's call this H, let's call this, I don't know, L, okay? Let's say I wanted to know the measure of arc BD, right? I wanted to know the measure of arc DH. I wanted to know the measure of arc LH. And I wanted to know the measure of arc LB. So I want to figure out the measures of all of those arcs, right? And some of you are trying to figure out how, what would you do? Always think of it this way. Before even working on all that, you can even figure out the angles. But one of them should be easy. We know that if the angle is 35 degrees, we know that this arc here is going to end up also being 35 degrees, right? Because again, if the central angle is 35, the corresponding arc has to be 35, right? So we know that BD is going to end up being 35 degrees. So we got that. And now think about things that we know. We know that this angle is 35 degrees. And if we look here, you see that that forms a straight line, right? And since that's a straight line, we know a line always adds up to 180. So if that adds up to 180, and we know that that's 35, can you figure out the missing angle? Again, remember, you got a line which adds up to 180 degrees, right? And since we want to find out what's missing, you would do 180 minus 35, which would end up giving you 145 degrees, right? So we know that, and again, it's all the idea. A line always adds up to 180, and you can check it too, because if that's 145 degrees and that's 35 degrees, when you add them together, it adds up to 180. And the good thing now is the same thing. If that's 145, the central angle, you know that LB is going to end up being 145 degrees too, right? Because again, arc, angle, always the same thing. LB is going to end up being 145 degrees. And now this, I don't know if you guys remember or not. Technically, you can add up, figure out everything with the line, but there's an easier way. Let's say you know this angle 35. Something we learned that whenever you have angles that are opposite of each other, they're called vertical. And the one thing we know about vertical angles, they're always congruent. So if that's 35, this one here is going to end up being 35 degrees, right? And if that's 145, this angle here is going to be 145. Because again, they're vertical, right? Always opposite each other, which means if they're vertical, they're always going to be congruent. And now the rest is done. Because if that's 35 degrees, this arc over here is going to end up being 35 degrees. And if that angle, central angle is 145, we know that the arc that goes with it is 145. So, you know, LH is 35. And you know that HD or DH, doesn't matter, is going to end up being 145. And if you really wanted to check, you can literally add up all 4 of these and you know you're right because all 4 of those should add up to 360 because it makes a circle. Let's try another one. See if you guys can actually piece these things together. And hopefully it's making sense, guys. And I hope you're finding this easier than you did last week or the week before too with all the slides. Just try one more. Alright. Again, you have another circle. Okay. You have the center, let's say. You have this line here. Now this is where I want you guys to be careful. You have this angle there. And now I'm going to draw it this way. And there are 4 things I want you guys to figure out. Let's say that this was A, that was L, this was Q, this was R, and I wanted to figure out, well, I'll give you this. I'll give you that this angle here, that central angle is 150 degrees. I want to figure out the measures of arc RA. I want to figure out the measure of arc AL. I want to figure out the measure of arc RQ. And let's say I wanted to figure out the measure of arc QL. Now 2 of those you guys should be able to figure out easily. And there's something that's also missing. I'm going to put over here that you're dealing with a right angle. And we'll get to that. So the one we should know automatically is if this angle here, the central angle is 150 degrees, you know that RA is also going to be 150 degrees. And going back to what we talked about before, that would also be a minor arc. And it's a minor arc because it's less than 180. Whereas if it was more than 180, greater than 180, it'd be a major arc. So one we know already for sure is RA. RA is 150 degrees. Right? Next one, again. Another one that should be very easy, some of you are starting to notice it quick, RQ. Now what we know is whenever we see the right angle, it's automatically 90 degrees. And if that's 90 degrees, the arc that corresponds to it's going to end up being 90 degrees. So we know that RQ is 90 degrees. The measure of RQ is 90. And now think, it's whichever one you want to do next. So let's focus on AL first, right? Again, it makes a line. So if that's 150, you would end up, to figure this out, you would do 180 minus 150, right? And again, the 180 is, it's a line. Line always adds up to 180. And when you subtract them, it gives you 30. And again, if you want to check to make sure that you're right, you know that 150 plus 30 adds up to 180, right? And if the central angle is 30, you know that arc AL is going to be 30 degrees too, because it corresponds. And again, since it's 30 degrees, since it's less than 180, it's going to be a minor arc. And last one. 2 ways you can do this. There's a complicated way, there's an easy way. If you wanted to, you could add up the 30, the 150, and the 90 and subtract it from 360, which would give you the right answer. Or you could also focus on the fact that this makes a line. And if that's 90 degrees, that has to be 90. Just because, again, a line always adds up to 180. And if that's 90, you know that LQ is going to end up being 90 degrees too. Let me get this out of the way so it doesn't confuse you guys. That's 90 degrees, which would make that 90. And same idea, guys. If you were to add up all 4 arcs, they should add up to 360 because it makes a circle. That's the whole lesson for today. Just want to make sure that you guys remember a few ideas, which is you got the center of a circle. You have the center of the circle. You have a radius of a circle. And again, always remember, the radius is half of a circle from the center to the side. So you know that from the center to the side of the circle is the radius. You know whenever you have it going, I won't crooked. You know that when you have it going from one side to the other through the center, you know that that's the diameter. And always remember, diameter is always double the radius. So if the radius is, let's say, 50, you know that the diameter is going to end up being 100 because it's double. And we have that. If I were to get rid of this segment right here, you know that this angle right here is called the central angle. And always remember, central angle always has to be at the center of the circle, always. And if we have a central angle, you know that the arc that corresponds to it is always congruent measure, same measure. And so again, if that's 38 degrees, you know that this arc here is gonna end up being 38 degrees. And don't forget the names of it. If that's an arc that's 38 degrees, you know it's gonna end up being a minor arc. And it's a minor arc because it's less than 180. If now you have the other arc, if we have an arc, let's say that's greater than 180 degrees, if it's bigger than half a circle, you know it's gonna be called a major arc. Guys, I hope this helped. If you have any issues whatsoever, feel free to let me know. Message me, send me a discussion comment in the group chat on Pearson, and I'm more than happy to help you guys out. But hopefully going forward, this will help you all out a little bit more. Take care again, be safe guys.